Alright, so let's get started then. Now, where we left off is the fact that we created a setting right here, right? A background, a middle ground, and a foreground, right? And also a player and enemy. The player has basic components, right? Transform, a sprite renderer, rigid body for physics, and collider for detection if it hits another game object like the enemy. And same thing with this enemy sprite right here, right, as highlighted through the hierarchy. Transformation, right, like position, rotation, scaling and such, sprite renderer, right, how it looks and viewed via image wise, rigid body for physics, and collider, just like the player. In the case of if it hits, something should happen, hopefully speaking. Now, let's go to the player itself, right? We want to do something in the case of movement, right? Have it move based on what you press on the keyboard and such. So let's do that. Now, think about this. We're going to create a script, a C# script. Think of it as giving a script to an actor and actress, but in this case you're going to give it to a game object, like this one right here. That's labeled as player sprite, correct? This game object that we currently have and working with. That's what's going to happen. It should follow a set of instructions through this C# script. Now, before we create this C# script, we should create a folder, just in case if we have more than one script to make it more organized. So I'm going to go to create, right? I'm going to right click and through the project and go to create and go to C# script, and I'm going to label it as players with an S, right? And there we are. Oops, sorry, I should create a folder, not a script itself. Not yet. Let me delete that for now. Click create a folder, and we're going to call it scripts, right? I'm going to create a folder called scripts that will hold all the scripts, and inside of it, double click it. We're going to create a C# script. Create C# script within the script folder. I'm going to call it players as such. There we go. Right now, I plan to add it to the player script. Right, I'm going to click on this through hierarchy, or click on it manually through the scene, which object I'm selecting. And here it is, right? All these components for this player script. I'm going to start adding the C# script. So there are two or maybe more ways to add this script. So I go to add component, and the script should be available right through here. And you could also create a new script through here when you click on new script and name it whatever you want. So I could also click and drag it into it. So I could click and drag to it, and now it's included, which is nice. So if I modify the script through here, it's automatically modified through the component. If I modify the script here, as such, if I click on the icon, gear icon that represents settings for the script, and click on edit script, right? Or double click this script here, the one I wish to select. Now, let's start editing this script and look at what we're dealing with. Here we go. Here it is. Now, for the player script, but yet, let me close this real quick, just in case. Open up. Here we go. So if we look at this player S script, here it is, right? And what I'm using is CodeWriter as a text editor. You could use other text editors, like maybe it automatically by default open to Notepad or some other edit script. You could use whatever edit script you want based on your preference, right? But right now I'm using CodeEditor, just for now in this case. So let's break down what we have so far. This one's created by default, right? Using system.collections, using system.collections generic, and using Unity engine. These are the three basic things that should be automatically created, and they are needed since it allows us to access other classes, other toolboxes in the case of maybe you want to reference or create some kind of variable or such. But yeah, let me remove this part right now. We're not working with this one. There we go. This is more empty. Sorry, I was working on something. So here we are, right? These are the basic 3 components that should be created and needed, right? It's like accessing a library in this case, right? And for this to access the library, we need usually these 3 basic components, right? That's all. And now we have the class components. Let me move this whole component for now, right? Control X to cut. I'm going to paste it back later. Now, for this one, the class, right? Think of it as a toolbox, right? Public class, the name of the class, and colon mono behavior. For this one right here, this is usually automatically named based on the name of the script, which is players, right? Should correspond to each other. If you have 2 different names, then there's a problem. It won't be recognized properly. So it's pretty much going to have the same. So if you rename your script, hopefully this one's automatically renamed, or you may have to rename it manually too, because they must correspond to each other name-wise, right? Then the mono behavior means that it's a base class, right? This is the main class that it's going to focus on. That's all. And now let's go with the other components, right? I'm going to go to Control V, paste it back. Now, if you look at it, better yet, let me Control X to take this in and just focus on this part right here. We have void start curly brackets, right? So I could even just remove this just for now. I could easily rewrite this. So we're gonna have a start function, and how it starts is void, right? Capital S start, parentheses, and curly brackets. And inside the curly brackets is usually where all the statements or code we're going to run. And how it works is this. Let's take a read on this one. It says start is called before the first frame update, right? So usually this runs maybe before or at the start of the game, right? Like when t equals 0, right? When the time equals 0 seconds, this code runs for 1 time only in this case, right? That's what's just happening, right? It's like setting everything up. It's like setting the stage up, right? The lights, camera, and action, all of that through code. That's all. And then we have, of course, update, right? And of course, how it works is this, right? This function, void, meaning, do you understand? Void means that it doesn't return anything, right? Void update, parentheses, and curly brackets. And inside these curly brackets, or between it, this is where our statements will be, right? Our code will be. And based on the reading, the comment itself, it says update is called once per frame, meaning it will run basically once per frame, right? After t equals 0, meaning after the start of time begins, or when this thing, or better, this game starts running, update will keep running, right? This is pretty important when we take in movement very soon, right? Now, when we think about movement or input movement for the player, we have to take account it as a value, which I'll show you very soon. So first things first, let's start creating our variable. We're going to place it inside the class, but outside of functions, right? I'm going to do this right now. We're going to make it public, meaning it's going to see through the game engine, through the inspector, which I will show and test it soon. Public, float, meaning it's going to contain a decimal value, and movement, right? We're going to call it as movement. And this will contains, oops, let's have it contain the x axis of movement. I will show you very soon what I mean by that. Now, that's one we have to take account, and maybe let's also take account the rigid body, right? So, physics part, let's just say, oops, physics part, right? Now, how we're going to state it as, we're going to place a public, let's have it view, you're going to see what I mean by that very soon. Public, rigid, body, 2D. And we're going to name it as rigid. Right? I'm referencing this component through, if you look at the inspector, right, through player, we're referencing to the rigid body, right, the physical component, and we're going to label it as rigid. We're going to start manipulating this variable very soon, right? So these are the two components we have to take account for now, right? Movement and rigid body. So let's say I want to take in movement. No, better yet, rigid body. Which one should we work with? A? Let's first work with the rigid body, right? Better yet, before we do that, let's see what happens, right? So let's do Control S to save, right? And let's see what happens when we run it. And I'll show you what I mean by that. It's gonna load, take a while. Click on this, and here we are, right? Here are the components that we created, right? In this case, right here. Movements and rigid body, right? That's labeled as rigid. Oops, let me click on that. Movements and rigid, right? And they're viewed through here, right? Through player sprites, grid inspector, the component itself, and the reason why we can see it is because we made it public. But let's say make one of them private, right? As such, it won't be viewed. Control S to save it and see what happens. And as you see here, movement is not seen because we believe it as private, meaning it can't be viewed at all through the game engine through the inspector of player sprites. Now, this is pretty important. We go down into maybe working in teams, right? At least two or so. Let's say there's game designer and game programmer. The game designer could be working on through here, through the view of the window views of the game engine Unity, while the game programmer works through here as a programmer, where he or she's making some components private, saying that, hey, you don't have to look at these components because that's not your job, right? Your job is to look and view the certain maybe components that are needed for your side, right? Whatever it's movement, rigid, or any sort of thing, correct? But let's say I run this. Let's see what happens with rigid. So here we go, rigid right now. And right now it's not doing nothing per se because we created the setup for movement, but we never gave it some kind of assignment, right? This basic thing, right? Public float movement, public rigid body, rigid, right? We have the movement parts and the physical component parts. Now let's start better yet, give an assignment or value to each of these two components, right? So let's do that right now. I'm going to go to the script, right? And I'm going to start this up. So let's have rigid equal get component, such parentheses and semicolon, right? This is something I'm going to assign to it. And in between this part, right here, oops, sorry, right here, I'm going to place in some kind of component name. In this case, it will be rigid body 2D, right? Because that's what we're taking in, right? We have to, before we modify anything to the physical component, we have to state that it's a reference in some way and officially assign it as a rigid body. as such. That's all to it, really. And of course, that's the start, right? That's how we get a step inside the start function, and that's going to the update function, right? Think of movement as a component that's happening over time, correct? In this case, once per frame. So we have movement, right? Assigned it as a certain input. So we're going to use the input class, right? This toBox, and access this certain tool called get access that will take account the access with parentheses in some way, right? Think of controllers, the toggle, right? How it moves around and such. We're going to take account the maybe horizontal component. So to do this, I'm going to use quotation marks, name it as capital H horizontal or horizontal as such, and it should take in the horizontal component, in this case x-axis, which I'll show you very soon. So let me save that right now, Control S as such. Take a while. Here we go. I'm gonna click on this. I should also do Control S to save this because it has the asterisk, right? So let me do Control S, save it as such, just in case. And let's start running this. So highlight it, clicked on it, right? As such, to see these two things. We're gonna see what happens. Let's play it. So right now, because I assigned it, right? What I mean by that is the fact that I assign these two things, right? Make it input get access horizontal and get component rigid body 2D, correct? And of course, right, I take an input, name function value, and I'm going to do get component, the name of the component, in this case 2D rigid body 2D. And remember that interesting thing is the fact that these two things should be pretty much the same, usually speaking, in the case of component wise, when you reference it or create an object, right? When you reference it and creating an object. Oops, sorry. Referencing and create an object for this name of rigid. So we did that, right? Now let's take a look at this side component, right? The rigid is automatically given assignments, in this case for the player sprite, right? Since it's included through here. And now let's start playing around with the input. So let's say I click on the left arrow, right, on my keyboard as such. It goes to -1. Take a look, right? Look very closely at the movement part. -1 to, if I go to the left, and if I go to the click on the right arrow to 1, it goes to 1. So when you think about it, it's like acting like it's on the x-axis, right? So it takes in that value, and we're playing around with it, just like moving horizontally, right, on the x-axis. If I go left, it's -1. That's its highest value right now. And if I go all the way to the right, it goes to 1 in this case. Now that we have made a bit of understand what's going on, let's go to the next step, right? We're gonna maybe have this baby, or better yet, this player start running and moving, right? So to do this, we're going to use something called fix update, right? This function, which will allow us to make it move, since in this type of movement, particularly with velocity. So when you think of velocity, it's speed and direction, correct? Because when you move around, you are moving at a certain amount of speed, and you're moving in a certain direction, right? Left, right, up, down, and such. So that's what we're gonna do, right? So I'm gonna place in the comments saying that where this fix update function will do this certain thing, where called multiple times per frame, right? Similar to update, but in this case it's calling multiple times per frame. So to do this, I'm going to do void, right? Fixed update, right? Capital F, capital U, and such. Update. As such, parentheses, curly brackets, all that's fun thing. Let me do this just for consistency. Here we go. And now I'm going to use reference of the rigid, right? Let's do that right now. Rigid. And I'm going to call a certain tool or function called velocity, right? Because that's the one thing where we want to manipulate to have it start moving. And assigned it as new vector 2, right? So what I mean by vector 2 is that we are taking account that it's a 2D game, right? So that means there's just an X and a Y when kind of manipulating, more or less. If you want to work with 3D components, then you do vector 3. But right now it's vector 2 because it's a 2D game we're working on right now. So we input these certain components inside between the parentheses where we take count movements, right? The value itself, correct? And let's have it associate with rigid dot velocity dot y, right? That means we're taking perspective of the y component of the velocity of rigid. I mean by rigid, I mean the rigid body component, the physics component. It's a bit weird, but that means we have to make it opposite in some weird way. I will show you very soon when we start taking account both the x and the y axis very soon. So that's that. Let's see what happens, right? Control S, right? And I could also show you this other concept, just give you more detail, right? Where, here we go, right? Similar to what we had before, the physical component, we're extracting or accessing this function called velocity and assigning new vector. So, sorry, new vector 2, right? Moving rigid dot velocity dot y. There we go. Okay, gotta fix that. Sorry about that. But here we go. This is the idea, right? We have this rigid body, right? Rigid as in case as a reference name. And we are able to access this function called velocity where we can manipulate the velocity, meaning we can manipulate the speed and direction, right? So in this case, the value of the speed, we just take out movement, right? What we saw before. And the rigid.velocity.y, right? Here we go, let's see what happens. So I saved it, right? As such. And let's see what happens if we go back to the game engine itself. And click on this, just to view what's going to happen through this script, right? Run it. Here we go. Ooh, take a look, it's moving, right? So if I go left, it goes to -1 and it's moving to the left. If I press the right arrow, it starts going to right, and the movement is 1, just like the x-axis, right? As such, so that's good. That's very good. Now, I feel like this is going a bit slow. What if we want to modify the speed, perhaps, right? We could do that actually, but that means we may have to multiply it, right? Multiply the amount of speed, make it twice the amount. It should be 3 times the amount, 10 times the amount, and so on. So let's create some kind of component, or better yet, variable, right? Just like movement. And it'll allow us to do this. So let's do this one, set up speed, right? This is what it's doing. Let's make it public so we can view it and maybe modify it through it, which I'll show you very soon. Public float speed equals, I suppose make it 10 maybe? 10 for now, right? semicolon, and let's multiply it through to the movement, right? Make it 10 times faster, perhaps? We could make it 10, but we want as such, but let's, this one, we're gonna make it reference to the variable speed, since we could easily modify it through publicly, which I'll show you very soon. For now, by default, it's 10, but we could modify it to something else. You'll see soon. Control S to save this. Great. And let's see what happens. It's gonna update, loading, here we go. Oh, here we go. Let's do this. Click on it. Here we are. There it is. Speed, right? It's 10. As such, correct. And it's multiplied to movements for an inside fixed update and such. And let's see what happens. Run it. And, ooh, it's faster, right? Because it's multiplied by the speed. In this case, speed contains the value of 10. But let's say I want to make it twice the amount. Make it 20. Will this make any changes? Run it. Yes, it does. Yes, it does. Right? Or lower it back to 5 maybe. So I can manipulate the value because it's viewed as public, right? So that's the great thing about this part of the game engine. It allows you to manipulate things publicly through the inspector component, specifically through the script, right? Because we made these components public, we can view it through here, since all of them are public. We can make it private if we want. It's up to you, really. So there's that. Now let's take account the Y perspective, right? Make it go up and down, not just left and right only. So let's do that right now. So let's do that. Now, to do this, we're gonna create another variable, just like movements, right? Contain the Y-axis of movement as such. Make it public. Make it float, just like movement. And let's call it movement 2. Semicolon. Yeah, it's lazy naming, but, you know, out of convenience, it's fine. Just make sure the naming is proper, something like this, so you have an idea of what it is, what it does, where it comes from, and such. It's up to you, really. Okay, so we did that, right? We declared it as a variable, right? Public scene, float meaning the decimal value, and the name of it 2 for now. Now let's go to update, right? Since this is some kind of value movement, and we're going to assign it in this case, since movement revolves around something that's happening over time, right? It's happening once per frame. In this case, that's why it's going to place it inside the update function. So let's do that right now. Movement 2 equals, so we're going to assign something, give it an input value and such. In this case, the axis, right? Input, meaning the class or toolbox itself, dot, meaning we're going to start accessing some kind of tool or function from the input class, get axis, right? And we're going to take in another component called vertical, right? With the quotation marks between it. But yeah, vertical, meaning we're going to take account of the vertical component when it goes up and down, right? And next, let's also have it start moving, right? So to do this, I would have to do it in such a way where I do rigid, right? Dot velocity, velocity, assign it to new vector 2, right? Since we are working with a 2D game and such. C's, semicolon. And then we're going to take in the same thing, just like this one, but modify it, right? So movement times movement 2, because it's take account the vertical component, right? As such, times the speed, right? Make it faster and such. You can manipulate whatever you want through speed, of course. We did before publicly through the inspector of the game engine itself. and then take out rigid.velocity, what speed are we manipulating via direction-wise, in this case the axis. So let's do rigid.velocity of y, because we're doing it in this case because vertical is y-axis, right? And then we have the horizontal, right? In this case the dot x, because the x-axis is horizontal, right, for movement, because movement is horizontal in this case, right? We have to do it in this such order because unfortunately that's how it is. So meaning have this one first and have this as second inside fixed update. The reason why, well, I'm gonna be plain simple. Well, there may be some kind of reason, because that's how it's read. But that's how it is. Worst scenario, but yeah, maybe that's how it is in this case. Oops, sorry, vector 2. Sorry, I have to do that part. But that's how it works. There may be a reason why we have to do it in such a way, or maybe there's a need to talk to the Unity developers of why it should be implemented in a certain order, chronological in this case. But it should work because we're taking account the velocity, right, and assigning it to the speed of some kind and direction, in this case the axis wise, the rigid dot velocity y, the y-axis in this case vertical, and the rigid dot velocity x, right, in this case for the horizontal components. So the speed should manipulate how the axis moves, how fast it goes, in this case direction wise too. Alright, that's enough talking or explaining about that fun part. Let's test it out if it works out or not. Control S, save it, and let's run this thing right here. So I go right, works, left, perfect. Click on the up button, nice. Click on the down button, perfect. So it looks amazing so far. But when I try to move to the left, maybe want to flip it, or look like it's going to a different direction. There is actually a way, but we have to do it based on a certain condition, right? So let's do that right now. Gonna cut it out. Now let's go back to coding, and we're gonna take in a component, or create a variable, right? In this case, a Boolean type. To do this, we're going to do this, make comments, say that this will set up flip, right? Variable, right? Because that's like these bunch of things, right? We are ready at these good ones right here, movement modes. Public bool is facing right. Let's call it that. So in this case, make public being viewed, bool meaning it's some kind of true false data type of some sort. It's going to give a true false. Is facing right. This will be the name for it, I guess, and make it equal to true. And why we're doing this, why we're setting is facing right true right now, because it is facing right and it's true is facing right. So we're going to assign it as true right now, and it's going to label it as is facing right in case as a variable, since it is facing right name-wise. Now, once we've done that, when you think of flipping, we have to take account that it could happen multiple times per frame, right? So that's where we have to use it within fixed update. So let's do that right now. So fixed update will take into if condition, right? If movement is, let's say, less than 0 and is facing right, then flip it. So what I mean by that, we'll call the flip function. We'll go into the flip function soon. We'll create it very soon, but I want to explain what I mean by this part, right? This condition or Boolean, more or less, inside this if. Now, what I mean by that is that if the movement is less than 0, right? Movement meaning the x component, right? In this case, horizontal. So when you see less than 0, right? We're talking about when the movement goes left, because it goes all the way down to -1, right? Let's go back here. It's going to -1, right? So if it goes left and is facing right, which is currently true, right? That means the picture, or better yet, the sprites, is facing right, but the movement left is going that direction, or better yet, spring press, and the value is going to -1. Ideally speaking, we want to make that sprite flip, correct? So by doing so, we want this sprite to flip. There's another scenario. Let's say we could place in, better yet, let me place parentheses just for convenience. Or, this is symbol for or, to understand this is symbol for and, right? Two and signs, two vertical signs, I would say. Special characters, basically. Or movement is greater than 0 and exclamation point is facing right. Meaning, if the movement is greater than 0, meaning it is going up to 1. When we view that, right, when we run that before, it means that when we're pressing the right arrow, it's going up to 1. So if the value or being pressed is going up to 1 and is facing right, not this part right here, the exclamation point, it basically flips the boolean from true to false, or false to true. So is facing right contains true, right? And with we have an exclamation mark, meaning that it's going to flip into false. Basically, it's indicating or saying that has the sprite or image of the player is facing left, and I input the right arrow or press the right arrow key, it's going to 1. That means we have to say that the sprite should be flipped to right based on the inputs. This may take a while. These bunch of things that I'm explaining, it may take a while for you to understand, but one step at a time. But for now, let's just keep going, and you could refer back to it, or watch this video over and over again till you see it, or do your own research to figure out what I mean by that. But right now I'm going to keep going, and maybe you'll see it soon. So all this if condition, right? If either of these conditions are met, right, it will start flipping, right? It's going to call the flip function. So after that's done, let's create the flip function right now. To do this, I'm going to do void as such, void flip disease. It's not taking any parameters or such. Curly brackets in between it. I'm going to create an object of some kind. I'm going to call it vector. Oops, vector 3. Call it player scale, and it's going to contain something called transform.local scale. What's happening is this. I'm referencing something called vector 3, right? Vector B, it's a certain class that will take in, right, this 3D perspective components. Even though it's 2D, we need something that allows us to rotate it, right, from 0 to 180 or such, right? When you flip an image to maybe to this, to the right, and we want to flip it to the left, that means we have to rotate it through the z-axis, right? That's why we need the 3D components. and we're going to reference or name it as player scale, right? This object. Or like a variable in this case. It's gonna be signed something called transform.local scale, meaning it's gonna contain some kind of value from the game out that contains this script in this case. So we could print something out through the console and I could show you what's happening. But I suppose I could do that later. Now, let's see what happens next. What should we do next? So right now, player scale, which has data type vector 3 for 3D components, is assigned transform.local scale, meaning it contains some kind of coordinates for the game object that contains that current script right now. Man. I suppose we could keep going, right? Once we created this whole thing, player scale could be manipulated because it contains that current value from the game of that codes that player script. So let's do it right now. So player scale, right? I'm referencing it, the variable object itself. And I'm gonna access the X component of it, right? And I'm going to assign it as player scale dot X times -1 semicolon. So what's happening is that I'm multiplying -1 to the X components of player scale. Player scale contains, of course, the current value or like position of the game object that holds this script. In this case, the which is the player sprite. I could also show you some kind of concept that could help, a visual concept that could help. So let's see, right here, right? What's happening is this. Transform.local scale, right? I am taking an X and Y component, right? Usually that's how it goes. It's just a very simple example. There's a more complex one, but I'm going to use this for now. Transform.local scale. It's going to take an X and Y component. It's going to do something, right? Let's say I have 5 as X, Y is 2, right? 5 equals X equals 5 for now. And let's say I have this kind of assignment, right? Something similar. I can place semicolon just for convenience or consistency for code-wise. But let's see what happens, right? X equals X times -1. What's happening is this. Let's say, what is X really, right? What's happening is this. Let's say I replace that X with 5 because X equals 5 from here in this example, right? As such. And this is what's happening, correct? I'm substituting it. And let's simplify it, of course, as such. Semicolon, semicolon, it's -5, and I'm reassigning it to X. I'm basically manipulating the value and reassigning it to itself, correct? And of course, it changes, like it's flipped, right? From 5.2 to -5.2, where it goes from 5 as such to -5 as such. So it's flipping, right? As such, like the X-axis in a weird, unique way. You know? That's how you could proceed as such. Right? You're multiplying -1 to itself, the exponent itself, and reassigning it to itself. Right? Make it flip via value-wise, like coordinate position-wise. Now, let's reassign it back to this current position of the player sprite itself, right? Because it contains the script itself. Transform.local scale equals player scale. Semicolon. And let's also modify or update the boolean where it's facing right, it not is facing right. So that means, for instance, let's say is facing right contains the value of true since it's boolean, and it's assigned a value or reassign a value where is facing right not facing is facing right. In this case, meaning if it contains true and it has an exclamation point, it turns to false, right? It's updating itself based on where it is, if it's going left or right in this case. So therefore, this one sets this setup, this one right here, this one transform by flipping in X components, right? And we're going to assign changed well, better yet, it's basically assigning to itself. I'm not going to place comment for now for this case. And this one, change the boolean, right? It's kind of weird, but surprisingly it works. In this case, where you're flipping it, you're containing the current position, right? Modifying the X component to make it flip by multiplying -1 and then reassign it to itself, assign it back to itself, and then changing the boolean just to update how it looks when you start moving to left or right. Whew. So once that's done, let's see what happens. Right, Control S. And I run it. Let's see, I go right, it's as it is. Better yet, I could also click on this to see what's going on through the script. Since it's all public, the components are variables itself. Go to left, whoops. Click on this, run this, right? You have to click on the scene just in case. Go left, it's going left, right? And that's another thing. Right, going left, right. And if you look at this check mark, it's acting as a boolean. So in this case, it's facing right, it's true. If it's facing left, it's false, right? It's unchecked. And if we want to check the movement too, which contains the y-axis, the vertical component, if it goes 1, it should be up, right? If it goes down, it's -1, right? You can also perceive it as this, as such, right? Moving vertically, right? Horizontally, -1, 1, y perspective, 1, and -1, right? This is acting like the x-axis, this is acting like the y-axis, horizontal and vertical, right? So we have that component. Maybe the final component I could show you as such is to create something that helps in the case detection. So to do this, a bunch of things we have to do. One is the fact that we must turn on the isTrigger components through the box collider of the player what we selected, right? Player sprite itself. And use some kind of reference which allows to tell us this is an enemy. So I created something like this, but let me create another one just for fun. Let me call it add tag right through the enemy. Call it purple ship. Save it, and I'm going to select it, and I'm going to change the tag instead of enemy tag, purple ship as an example. Here we are. This is labeled as purple ship right now. tags are used for references. It could also be references through code, which I'll show you very soon. So I go to my code right now, right? And let's create a function called private. Let's make it private for now, of course. Private void on, capital T, trigger, right, since the trigger is on or checked through the player. Correct. Is on trigger, enter 2D, and it's gonna take in a potential data type or component called collider 2D, right? Since this enemy right now currently holds some kind of component as this box collider. Let's also have this checked just in case, right? And this collider should reference some kind of potential game object, right? So we have that part. Let me go back to here, right? So we're gonna call it maybe a generic name as other. Use curly brackets. Between it or inside of it, we're going to use an if condition, right? It's going to say if this potential other game object or component dot tag, reference to tagwise, right, is equal to, using 2 equal sign as such, represented as equal to this certain string through the tag called, let's say, purple ship, right? As we did before through here. Tag purple ship through enemy sprites. And what should we have it do? If the player that holds the script hits a game object with a tag of purple ship, what's gonna happen is maybe we want to create, or better yet, have the player destroy itself if it touches the purple ship, because the purple ship more or less right now is representing as the enemy. So destroy the current game object that holds this script, right? In this case, we're going to reference the game object itself as game object with a capital O, game object, right? So if this game object that holds the script touches a potential enemy that holds some kind of tag as purple ship, the game object that holds this script will destroy, right? With the function destroy and parameter within it, or argument within it, it destroys, right? Destroy player in this case. It's holding, this script is holding the player. The script is included in the player itself. Let's see what happens. Control S, right? And I run it. Compiler. Let's see what happens. I think I forgot a semicolon. All statements, everything, including function, you must have a semicolon no matter what. Control S, right? So here we go. Run it. Touch it. Destroy it. Because it's hitting something that is tagged with purple ship as such. Right? We could also reference it through name. In this case, through the name it's perceived as, through, you could view it through the hierarchy. So we could, instead of using the tag as reference, we could use the name as a reference, right? If this potential game object that has a name called, if I'm correct, enemy sprite, correct, as such, if we select it, here it is, highlighted. That's the name of it, through the hierarchy. Let's see what happens. We'll do the same thing. Control S. Loading, here we go, run it. Boom. Yes, this game object is destroyed. If you see it, it's also, the name is disappeared, with the game object itself indicating the game object or player is destroyed or gone and deleted during this current run of the game. So that is the whole basics of movements and a little look of modifying the speed, the physics, the controls, the how foot works in the case of transformation, and in the case of collision, basic collision based on name and tag as a reference. That's all, and that's it. So Control S to save, right? Asterisk is gone, meaning it's saved, and remember to save it through collab. So what we did together is the fact that we created movements, right? So I'm going to place this as update. You can place whatever comment on, or place no comments at all. Update, created movements, speed. Let's see, we also created flip and collision, right? Based on conditions, based on a tag or name as a reference. Publish now. As such, takes a while, of course. And now it's saved all the way through the cloud, through Unity dashboard. Just in case if this game project is magically deleted locally on your computer, you could easily re-upload it or re-download it through the cloud. Alright, that's it.